So in the last several lectures, we've been talking about the slope-intercept equation, looking at ways that we can use that to find the equation of a line. And the slope-intercept equation is great. If you know the slope and you know the coordinates of the y-intercept, it's super simple to use. Trouble starts when the point that you have isn't the y-intercept. Right? Then it turns into this two-step process. First, you have to use the slope equation to find the slope. Then you have to substitute that in your point. You have to solve another equation to get the value of b. It's more work, right? And more work means more opportunities to make some silly mistake, right? So there's another equation. It's going to kind of help us out with this. It's called the point-slope equation. And it starts off in the same place, right? Suppose we know the slope of a line and the coordinates of a point on it. I'm going to call those coordinates x1, comma y1. Right? Then the next step is I'm going to say, well, look, I need a second point, right? And I'm going to let the coordinates of that point be x, comma y. Now those aren't numbers, right? Those are going to be our variables, right? So what I'm going to do is I'm going to take the coordinates that I know and the coordinates with these variables, and I'm going to say, okay, look, let's go to the slope equation, right? And what I'm going to do is I'm going to take x and y and let them be x2 and y2. Right, so if I put those variables into the equation, it looks like this. Right, now technically that is kind of the equation that we need, but it's not written in a very useful way. Right, so I'm going to manipulate this a little bit, turn it into something that's maybe a little more useful. Right, so what I'm going to do first is I'm going to get rid of the denominators. Right, I'm going to multiply both sides by x minus x1. That's going to cancel them out on the right-hand side. Right, and if I do that, kind of turn things around and put the y's on the left-hand side, because that's how we usually write these sorts of things, my equation looks like this. And that is the point-slope equation. All right, so let's see how we can use this thing. I have an example here. Right, I want to find the equation of the line that goes through those 2 points. Now, remember, we talked about this before. The two things you have to know to find the equation of a line are a point on the line. We're squared away. We've got 2 of those. And you need to know the slope of the line. Right, well, I don't know that yet, but I can calculate it. We're going to go back to that slope formula. And I'm going to substitute my numbers in here. This is going to be, I'm going to do 5 minus 6 over 2. Now be careful here. This is minus 1. So 5 minus 6 is negative 1. That's 2 plus 1 down there in the denominator. That's 3. Okay, now I've got my slope and I've got some points. So now I'm ready to go to my new equation, my point-slope equation. Okay, so what I'm going to do first is I'm going to stick negative 1/3 in there for the slope. And now I need to pick one of the 2 points. Doesn't matter which one. And you don't have to trust me on this. When we're done here, try doing it with the other point, and you'll see you'll get the exact same answer either way. Right, so I'm going to pick the 2, 5 point. Right, for no other reason than both of those numbers are positive. Right, and we talked about this before in some other examples. You've got the minus y1 minus x1. If I try putting a negative number in there, now I have negative negatives. It's just one more thing complicating the situation. So if I have the choice, I'm going to go with points that are just positive. Right, so I'm going to put x minus 2 here. And I'm going to put y minus 5 here. Okay, so far so good. Right? And technically, again, that's not an unreasonable answer. But with these questions, usually you want the equation solved for y, right? One variable equals some formula with the other one. Right, so that's what I'm going to do here. Now, you notice there's a fraction. Right? And a lot of time, we'd kind of rather not dance with fractions if we don't have to. So what I'm going to do here is I'm going to multiply both sides of this equation by negative 3. Right, on the left side, if I do the distributive property here, this is negative 3y plus 15. And over here on this side, these 2 negatives are going to cancel each other and become positive. And the 3's cancel. And I don't have that fraction anymore, just x minus 2. All right, so now we're almost there. We'll subtract 15 from both sides. This becomes minus 3y equals x minus 17. And then I'll divide everything by -3. They'll cancel over here. That's what I was looking for, right? Y equals something. On the left-hand side, it's negative, excuse me, right-hand side, it's -1/3 x plus 17/3. And there's the equation of my line. So now we have these two methods for finding the equation of a line. In the next lecture, we're going to look at two special cases. All of the lines we've looked at so far, there's an x and a y, two variables in the equation, and if we graph them, they come out looking like diagonal lines. Well, the two special cases that we need to think about are horizontal and vertical lines. Right? The equations for those two are going to look a little bit different, and we'll see more about that in the next lecture.